Hi everyone, welcome to another GCSE physics video by SMARTPATHTUTORING. This is about electric motors and loudspeakers. A current carrying coil of wire rotates in a magnetic field. The diagram on the right shows an axle that passes out of the two ends of a coil of wire that's carrying a current. These forces are just the usual forces which act on both the sides, as in question number 4. Because the coil is at a right angle to the forces acting on the up and down, it rotates. The split ring commutator is a clever way of keeping the contacts touching but allowing the motor rotating at the same direction. The direction of the motor can be reversed either by swapping the polarity of the supply, reversing the current, or swapping the magnetic poles over, reversing the field. You can use Fleming's left-hand rule to work out which way the coil will turn. Example: is the coil turning clockwise or anti-clockwise? Draw in current across from positive to negative. Use Fleming's left-hand rule on one branch. Here I have picked the right-hand branch. Paint your first finger in the direction of the magnetic field. Remember, this is north to south. Paint your second finger in the direction of the current. Draw in the direction of motion, the direction your thumb is pointing in. The coil is turning anti-clockwise. Loudspeakers work because of the motor effect. Loudspeakers and headphones, which are just tiny loudspeakers, they both use electromagnets. An alternating current is sent through a coil if wire attached to the base of a paper cone. The coil surrounds one pole of a permanent magnet and is surrounded by the other pole, so the current causes a force in the coil, which causes the cone to move. When the current reverses, the force acts in the opposite direction, which causes the cone to move in the opposite direction too. By varying the current inside the coil, the cone vibrates the air around the cone while it moves. The vibrations in air produce a sound we hear. The frequency of the sound waves is the frequency of the AC, so by controlling the frequency of the AC, you can alter the sound produced. Thank you for watching, and make sure you subscribe to our YouTube channel.